Hey there, YouTube. I was checking out my safe the other day and I found this in my safe. I bought this about 20 years ago used. It's a Ruger 1022. It has the kind of crappy iron sights that come factory installed. And I don't think I've actually ever shot this gun, despite the fact that it's the most popular semi-auto 22 in the world. But what I thought I would do is help use this gun to teach the principles of accuracy and precision in shooting. I have a math background, and I promise not to get too nerdy with you, but I was going to teach you how to actually calculate accuracy and precision of your gun and of your shooting. So I hope you really enjoy this, and leave your comments and suggestions. So what I did here is I bought a large piece of graph paper where each of the squares is 1 inch by 1 inch. And I simply dropped a vertical and horizontal line to indicate the bullseye target. We'll use these squares to measure the accuracy and precision of our shots. You can buy about 10 of these for $5. So I'm going to go ahead and shoot about 20 shots here, and you can tell, even if you don't know what accuracy and precision really are, that they're probably not that good. I had never shot this gun before, so we're going to explain this whole situation. So the first big concept is this distinction between accuracy and precision. Accuracy refers to how close you are to the bullseye. Did you get the bullseye? Precision refers to how close the shots are to one another. This is what has been referred to as the, quote, spread of the impacts. This has its roots in statistical language. If the shots are very close to one another, your shooting is precise. There is an accuracy measure and precision measure for both elevation and windage. Thus, there will be 4 possible variables to solve for. First, let's do some terminology. Each one of these squares on the graph pad is 1 inch by 1 inch. You can get different size graph pads, but for this example, it's 1 inch by 1 inch. So the dot in the middle represents the bullseye that we're shooting at. Any shots above the horizontal line would be considered off high from an elevation standpoint, and any shots below the horizontal line would be considered off from an elevation standpoint low. In a similar way, any shots to the right of the vertical line would be off from a windage standpoint, and any shots to the left of the vertical line would be off from a windage standpoint as well. I'd like to provide a few examples. This example here demonstrates both poor precision and accuracy for both elevation and windage, and this is because the shots do not hit the bullseye, and they're off above the horizontal line, below the horizontal line, and also to the right of the vertical line. If you look closely, you can tell that the shots are more off on the right from a windage standpoint and high from an elevation standpoint. Here's a good example where the precision is pretty good for both elevation and windage. That is, the shots are grouped tight. But, as you can see, we're pretty far away from the bullseye, the blue dot, so the accuracy is poor. This is a super cool example. It actually represents perfect accuracy and precision for elevation because all the shots are on the horizontal line. However, it's very, very poor accuracy and precision for windage. Now, here's the thing. You can actually mathematically measure accuracy and precision. Accuracy would be the average of your shots. Precision is a little bit more complicated. Precision would be the 95% confidence interval that is defined as the range of shot locations where 95 out of 100 shots would be located in. This is the same as the range defined as plus or minus 2 standard deviations around the average. Don't get too worried about standard deviation. It's simply a measure of the spread of data. It is easily calculated from Excel, and I'm going to show you how to do that now. All you have to do for your calculation is to measure each shot with respect to the X and Y axis. This goes back to basic math from high school. In this example here, there's a shot that is 7 inches to the right and 3 inches high. We're going to record that on the Excel spreadsheet for all of our shots. Simply open up Excel, and in the first column, list all of your shots, 1 through 20 in this example. And then in the second column, put the measurement for windage, which is, again, the x-axis measurement, and that can be either positive or negative, depending on which side of the vertical line you're on. And you'll do the same thing for elevation, which will be the shots that are above or below the horizontal axis. That's the y-axis. So list all these numbers in the column, and then you have the complete data needed to make the calculation. And you can see here in column E, I have some labels for different variables. Just copy these down as listed here, and I will explain. So the first thing that we're going to do is figure out the average. So just type this formula equals into the bar like this and click average, and then highlight the data fields that you want to average. We're going to do windage first. Highlight the box, hit enter. Because I want 2 decimal points precision, I go up to this little area here and I click that to change my cell to give 2 decimal points. And then I will repeat the same steps for the average on elevation. So we'll say equals, and we'll find the average formula, and we'll highlight the data fields there, hit enter, and that'll give us the average elevation. And in a similar fashion, we'll make sure that we have 2 decimal points of precision by clicking that little button there. Next, we're going to calculate the standard deviation for both windage and elevation. So we'll start with windage, and you will enter your equal signs again to bring out your formulas, and then type in ST, and you'll see ST-DEV shows up here. That stands for standard deviation. In a similar way that we did the average, we'll just highlight the windage data fields, hit enter, and that gives us the standard deviation. I don't need this much precision, so I will go back to my little box there, and I'll reduce the number of data points past the decimal point here, back to 2, just like I did for average. Now we're going to repeat the same process for the standard deviation for elevation. And just remember, the standard deviation is just a mathematical formula that summarizes how widely spread out the data points are. So if the shots are all over the place, the standard deviation is going to be large, and if the shots are really close, the standard deviation will be pretty small. Our next job is to multiply the standard deviation by 2. So you can do that with a simple formula here, and you can just highlight the cell where the standard deviation lives. And of course, we'll reduce the decimal points to 2. And we're going to do that again, but this time it's going to be negative. Just make a negative sign, and I'll explain what this all means in a second. Let's repeat that for the elevation. So standard deviation times 2 will get your number, and you get it down to 2 decimal points, and then the next cell you make negative. So what happens is we can take those 2 numbers and essentially add them to each side of the average to figure out the 95% probability range where the shots are going to end up. So that's what I'm doing here. So I take the average, I highlight that cell, and I'm going to add to it the value that goes to the left, and then I'm going to go do that again for the side that goes to the right for the windage. And we will repeat this for the elevation. So for the shots going low, we'll take the average elevation and we'll add to it the negative value in this cell here. And for the shots going above, we'll take the average and add to it the positive value. Now all we have to do is take these 4 data points and put them on our graph. Then we create a rectangle, and this rectangle represents the zone where 95 out of 100 shots will land. And as long as this zone covers all the vital areas on your target, like those of a deer, you're all set. So in conclusion, accuracy is defined as the average or mean of the shots. It's a numerical value, how close you are to the bullseye. Precision is the spread of shots defined by the standard deviation. It refers to how far apart the individual shots are. There are accuracy and precision measurements for both elevation and windage. So the most important thing to do is create what I like to describe as the probability rectangle, calculated from your sample shooting, where 95% of your shots will land.